Okay, this lesson is on triangle theorems. There's two we're going to talk about today, the triangle inequality theorem and the triangle sum theorem. The triangle inequality theorem states that the two smaller sides of a triangle must add to be larger than the third side. Okay, so typically in a triangle, C is always represents the longest side. So A plus B, when I add them together, they have to be larger than C. So if somebody tries to trick you and say, hey, can a triangle be any three lengths? You could say no, the two small sides have to add to be larger than the third side. So let's look at these examples right here. So maybe let's say these are the two short sides. Okay, so I'm going to add them together, 13 plus 19, and that's going to be 32. Okay, so that means that if these are the two short sides, if I add these together, the third side has to be less than 32. So it can't equal it, it's going to have to be less than. So this side right here, x, if I add it together, x has to be less than 32, because if these are the two short sides. But what if this isn't the longest side? What if this is the shortest or the longest side? Then that means these two together have to add to be larger than 19. So to find that, I'm going to take the two numbers that I do know, 19 minus 13, and I'm going to get 6. So that means that this third side has to be greater than 6. So check it out. If this was 6, 6 plus 13 is 19. So that equals that. So that's not going to work. That's why it has to be greater than 6. So it could be 6.1, then it'd be 19.1. So always, to find the maximum and minimum lengths for the sides, you're going to take the two numbers that you have and you're going to add them and you're going to subtract them. So let's do that on the next problem. If I add 15 plus 14, I get 29. And if I subtract 15 minus 14, I get 1. So I'm looking for these two numbers here because the missing side, I'll call it x, the missing side has to be between those two numbers that you just found out. And so here, that means if I call this side C, because typically you see ABC, ABC has to be less than A plus B, and it has to be greater than A minus B. Okay, so whatever that is. All right, we'll practice on the next page, but let me teach you the second theorem. The second theorem says the triangle sum theorem. And what that means is that the three angles of a triangle, A plus B plus C, must always equal 180 degrees. Okay? The three angles of a triangle always add to 180 degrees. And that is the same for every triangle that exists. It doesn't matter if it's a big triangle or a little tiny triangle, okay, or a triangle shaped all silly, but the three angles here add to 180, the three angles here add to 180, and the three angles here add to 180. Okay, let's look at these examples. So I want to know what are the measurements of these. I want to find the missing x. So the missing x, I know that these three angles, x plus 40 plus 80, all have to equal 180. Okay, well, x plus 40 plus 80 is 120 equals 180. I'm just solving for x. Subtract 120 from both sides. I find out that x is 60 degrees. Some of you might have been able to look at that and go, well, this is 80, and then 40 plus 60 is 100, so there's 180. Okay, you could also just do it that way if you noticed that. But if not, set up your equation. You know that the three are always going to add to 180. Let's look at this problem over here. three angles in a triangle. So if I take 2x plus 96 plus x plus 12, those are the three angles of a triangle, and we know they're all going to add to 180. So combine like terms. Here I have an x and a 2x on the same side, so that's 3x plus 96 plus 12 are both constants or just plain numbers. So we're going to go add that together and get 108, and that equals 180. So if I subtract 108 from both sides, because our goal is to isolate the variable, you're going to get 3x equals 72, okay? Divide by 3, and x equals 72 divided by 3. That goes in there twice. 12, that goes in there 4 times. So x equals 24, okay? Yay! That's how simple this lesson is. 2 theorems, all right? Remember, when you go into Delta Math, you should have your notes out and be looking at them. So we're going to practice these. Examine each diagram. Which diagrams are possible, which are impossible? Justify each conclusion. So, is this possible? Is this triangle a possibility? Can I have 5, 14, and 20? Well, remember, in this problem, the sides A plus B have to be greater than C. These are the small sides, and this is the large side. So 20 is the largest number, so let's put that for our C. So that means we have to see if this is a true statement. Is it true that 5 plus 14 is larger than 20? Well, 19 is larger than 20. This is false. So this is not possible. This triangle is not possible. You can't have those lengths in a triangle. Let's look at part B. This one is checking the angles inside. So we're going to say 63 plus 59 plus 57. So we're going to get, let's see, this is going to be 60, 120, 189. Is that possible? Can these three angles add up to 189? Again, this is false, okay? If I set that equal to 180 and I want to see if that's true, I get 189 equals 180. That's false. So again, this one is not possible. Okay, we're checking to see if these can actually be triangles the way they are. So let's look at the next one. Okay. So this is another one. Since I'm talking about the sides, I have to add the two smaller ones up. So A plus B has to be greater than C. C is always the largest. So the two small ones are 2 plus 24. Is 2 plus 24 larger than 25? 26 is greater than 26, so this is true. This is possible. Okay, and the next one. Well, let's see. 62, 59. So we can figure out what this is right here. 62 plus 59 plus our unknown, I'll call it x. I'll change this to x so it matches. That should equal 180. So let's see, what do we get? 121 plus x equals 180. So let's subtract 121 from both sides and see if this is possible. We're going to get x equals 59. So is it possible that this equals 59? Okay, well, we put these 10s in here, right? We know that those two sides are both 10. So that means the angles across from them have to be the same length. So 59 is across from this 10. So the other 59 should also be 10, but it's over here. So we don't know what it is. So I can't have a 59 and a 62 across from sides that are the same. This is just not going to work. Not possible. Okay. The same measure angles must be across from same, measured sides. Okay, so if I have two angles that are the same, the sides across from them have to also be the same. So this could be 10, but this can't be 10 because 62 and 59 are not the same, so their sides that they're across from can not be the same. All right, let's look at this last example. Examine the angle pair relationships in the diagram. Write and solve an expression for x and y if possible. Well, let's see. I noticed that the relationship between 119 and y, I noticed that first because I can make a rainbow. I love making rainbows. Where do rainbows happen? In lovely places. And lovely places, when you translate to math, that's a linear pair. A linear pair is supplementary. Supplementary equals 180. So we know that 119 plus y should equal 180 degrees. So when I subtract the 119, I can solve for y. I get y equals 61. So this is 61 degrees. All right. Then what else do we notice? Let's see. We notice that we want to find this angle right here. Okay, so what's the relationship between that angle and another angle? Well, I see this is in the top right and y is in the top right. So these angles that I just drew in blue, they are in the same position. And in the same position, that makes them corresponding angles, Okay, so corresponding angles, what do we know about them? If we look at our notes, or you wait a second and I'll tell you, but if we look at our notes, you should be thinking, oh, corresponding angles, those are congruent. And congruent means that they are the same measure, same size, same shape, same measure. So I know that this 5x plus 11 should equal 61. So let's subtract, and we get 5x equals 50, or x equals 10. All right, I just solved for that. So that's the reasoning behind that. You'll have more practice with those types of problems on Delta Math. And pay attention to the directions for Delta Math, because I want you to take a picture of your work. I can look on Delta Math and see that you got to 100%, but I want to see the work that you did on a piece of paper, scratch paper, the back of, I was going to say the back of my worksheets, but mine are blank and yours are probably printed on. Yeah, have a great day.